Greetings children. We now come to part 2, magnetic effects of electric current. Let's start.
Question 1. State any two properties of magnetic field lines. Solution. Prop of magnetic field lines. I. The magnetic field lines originate from the north pole of a magnet and end at its south pole. 2. The strength of magnetic fields is indicated by the degree of closeness of the field lines. Where the field lines are closest together, the magnetic fields is the strongest there. Question 2. What are the two ways in which you can trace the magnetic field pattern of a bar magnet? Solution. I. By using iron filings. 2. By using compass. Question 3. You are given the magnetic field pattern of a magnet. How will you find out from it where the magnetic fields is the strongest? Solution. Magnetic fields is the strongest at the place where the magnetic field lines are closest together.
The bar magnet. The bar magnet has two poles. These poles are North Pole and South Pole. The region around the magnet in which it exerts force on other magnets and on the object made of iron is called a magnetic field. We can scatter iron filings in the region. The iron filings tend to line up and form chains. The orientation of these chains indicates the direction along which magnets line up. The iron filings became little magnets by introduction. Magnetic lines of force. We can visualize electric field with the electric lines of force. Similarly, we can also visualize magnetic fields by magnetic lines of force. The path followed by the north pole of a test magnet in a magnetic field is called a magnetic line of force. When we can draw lines of force due to a bar magnet, we find magnetic line of force emerge out from its north pole and converge into the south pole. We know that electric lines of force emerge out from positive charge and converge into negative charge. If we place a magnetic compass in a magnetic field of a bar magnet, the needle of compass aligned along the lines of force. Properties of magnetic lines of force. 1. These are smooth closed curves which start from north pole and on to the south pole outside the magnet, and they move from south pole to north pole inside the magnet. 2. The tangent at any point on the lines of force gives the direction of magnetic field. 3. They never intersect each other. If they intersect, it means the field has two directions, which is not possible. 4. Magnetic lines of force are straight and parallel in a uniform magnetic field. Magnetic dipole and dipole moment. A pair of poles of equal and opposite strengths separated by some distance is called magnetic dipole. A bar magnet has two poles of opposite kinds, therefore it can be called as a magnetic dipole. The magnitude of dipole moment is a product of the pole strength and the separation between the poles. M is equal to M into 2L. Inverse square law of force in magnetism. Let us consider two magnetic poles of strengths M and M' separated by a distance R. The poles of strength M' is the field of pole strength M. The force between them is F is directly proportional to M' by R square. F is equal to mu naught by 4 pi M' by R square. This is the inverse square law in magnetism. Magnetic flux density B.
Q4. State whether the following statement is true or false. The axis of Earth's imaginary magnet and the geographical axis coincide with each other. Answer: false. The axis of Earth's imaginary magnet and the geographical axis are inclined to each other 15 degrees. Q5. Why does a compass needle get deflected when brought near a bar magnet? Answer: a compass needle gets deflected when brought near a bar magnet because the needle experiences a magnetic field exerted by the bar magnet. Q6. Where do the manufacturers use a magnetic strip in the refrigerator? Why is the magnetic strip used? Answer: magnetic strips are used in the doors of the refrigerator to keep the door closed. Q7. Fill in the following blanks with suitable words. A. Magnetic field lines leaves their pole of a bar magnet and enters its. B. The Earth's magnetic field is rather like that of a magnet with its pole in the northern hemisphere. Answer: A. North and south. B. Bar and south. Draw a diagram to show the magnetic field lines around a bar magnet. Question 9. What is a magnetic field? How can the direction of magnetic field lines at a place be determined? Solution. The space surrounding a magnet in which magnetic force is exerted is called a magnetic field. The direction of magnetic field lines at a place can be determined by using a compass needle. A compass needle placed near a magnet gets deflected due to the magnetic force exerted by the magnet. The north end of the needle of the compass indicates the direction of magnetic field at the point where it is placed. Question 10. Explain why two magnetic field lines do not intersect each other. Solution. Two magnetic field lines do not intersect each other due to the fact that the resultant force on the North Pole at any point can be only in one direction. But if the two magnetic lines intersect one another, this means that resultant force on a North Pole placed at the point of interaction will be along two directions, which is not possible. Question 11. When an electric current is passed through any wire, a magnetic field is produced around it. Then why an electric iron connecting cable does not attract nearby iron objects when electric current is switched on through it? Solution. Because the strength of magnetic field produced by the cable is quite weak. Question 12. A. Define magnetic field lines. Describe an activity to draw a magnetic field line outside a bar magnet from one pole to another pole. B. Explain why a freely suspended magnet always points in the north-south direction. Solution. A. The magnetic field lines are the lines drawn in a magnetic field along which a north magnetic pole would move. The magnetic field lines are also known as magnetic lines of forces. Activity to draw a magnetic field line outside a bar magnet from one pole to another pole. Take a small compass and a bar magnet. Place the magnet on a sheet of white paper fixed on a drawing board, using some adhesive material. Mark the boundary of the magnet. Place the compass near the north pole of the magnet. The south pole of the needle points towards the north pole of the magnet. The north pole of the compass is directed away from the north pole of the magnet. Mark the position of two ends of the needle. Now move the needle to a new position such that its south pole occupies the position previously occupied by its north pole. In this way, proceed step by step till you reach the south pole of the magnet. Join the points marked on the paper by a smooth curve. This curve represents a magnetic field line. B. A freely suspended magnet points in the north-south direction because Earth behaves as a magnet with its south pole in the geographical north and the north pole in the geographical south. Q13. A strong bar magnet is placed vertically above a horizontal wooden board. The magnetic lines of force will be A. Only in horizontal plane around the magnet. B. Only in vertical plane around the magnet. C. In horizontal as well as in vertical planes round the magnet. D. In all the planes round the magnet. Answer: the correct option is D. In all the planes around the magnet. Q14. The magnetic field lines produced by a bar magnet, A. originate from the South Pole and end at its North Pole. B. originate from the North Pole and end at its East Pole. C. originate from the North Pole and end at its South Pole. D. originate from the South Pole and end at its West Pole. Answer: the correct option is C. originate from the North Pole and end at its South Pole. Q15. Which of the following is not attracted by a magnet? A. Steel. B. Cobalt. C. Brass. D. Nickel. Answer: the correct option is C. Brass. Q16. The magnetic field lines, A. intersect at right angles to one another. B. intersect at an angle of 45 to each other. C. do not cross one another. D. cross at an angle of 60 to one another. Answer: the correct option is C. do not cross one another. Q17. The North Pole of Earth's magnet is in their A. geographical south. B. geographical east. C. geographical west. D. geographical north. Answer: the correct option is A. geographical south. Q18. The axis of Earth's magnetic field is inclined with the geographical axis at an angle of about A. 5 degrees, B. 15 degrees, C. 25 degrees, D. 35 degrees. Solution: the axis of the Earth's magnetic field is inclined at an angle of about 15 degrees with the geographical axis. So, the correct option is B. Q19. The shape of the Earth's magnetic field resembles that of an imaginary A. U-shaped magnet. B. straight conductor carrying current. C. current carrying circular coil. D. bar magnet. Answer: the correct option is D. bar magnet. Q20. A magnet attracts A. plastics. B. any metal. C. aluminum. D. iron and steel. Answer: the correct option is D. iron and steel. Q21. A plotting compass is placed near the south pole of a bar magnet. The pointer of plotting compass will A. point away from the south pole. B. point parallel to the south pole. C. point towards the south pole. D. point at right angles to the south pole. Answer: the correct option is C. point towards the south pole. Q22. The metallic pointer of a plotting compass gets deflected only when it is placed near a bar magnet because the pointer has A. electromagnetism. B. permanent magnetism. C. induced magnetism. D. ferromagnetism. Answer: the correct option is B. permanent magnetism. Q23. Which of the following statements is incorrect regarding magnetic field lines? A. The direction of magnetic field at a point is taken to be the direction in which the north pole of a magnetic compass needle points. B. Magnetic field lines are closed curves. C. If magnetic field lines are parallel and equidistant, they represent zero field strength. D. Relative strength of magnetic fields is shown by the degree of closeness of the field lines. Answer: the correct option is C. If magnetic field lines are parallel and equidistant, they represent zero field strength. Copy the figure given below which shows a plotting compass and a magnet. Label the end pole of the magnet and draw the field line on which the compass lies. Solution: as the north pole of the magnetic needle is pointing in the opposite direction, so the nearer end of the magnet will be north pole. Question A. The diagram shown a bar magnet surrounded by 4 plotting compasses. Copy the diagram and mark in it the direction of the compass needle for each of the cases B, C and D. B. Which is the north pole, X or Y? Solution: refer to the diagram in the solution. B. X is the north pole. Question: the 3 diagrams in the following figure show the lines of force, field lines, between the poles of 2 magnets. Identify the poles A, B, C, D, E and F. Solution: A. North pole. As field lines are going away. B. North pole. As field lines are going away. C. South pole. As field lines are coming towards. D. South pole. As field lines are coming towards. E. North pole. As field lines are going away, F, South Pole. As field lines are coming towards. Question: the figure given below shows the magnetic field between two magnets, I. Copy the diagram and label the other poles of the magnets. 2. Which is the weaker magnet? Solution: I2. Magnet 2 is weaker because the magnet 1 is more dominating. Very short answer type questions. Q1. Which effective current can be utilized in detecting a current carrying wire concealed in a wall? Answer: magnetic effective current can be utilized in detecting a current carrying wire that is concealed in a wall. Q2. What conclusion do you get from the observation that a current carrying wire deflects a compass needle placed near it? Answer: the conclusion that is drawn by observing a current carrying wire that deflects a compass needle is that there is a production of magnetic field around the needle. Q3. Name the scientist who discovered the magnetic effect of current. Answer: Ørsted was the scientist who discovered the magnetic effect of current. Q4. State qualitatively the effect of inserting an iron core into a current-carrying solenoid. Answer: when an iron core is inserted into a current-carrying solenoid, the magnetic field becomes very strong. Q5. Name the rule for finding the direction of magnetic field produced by a straight current-carrying conductor. Answer: the rule for finding the direction of magnetic field produced by a straight current-carrying conductor is Maxwell's right-hand thumb rule. Q6. State the form of magnetic field lines around a straight current-carrying conductor. Answer: the magnetic lines around a straight current-carrying conductor form concentric circles. Q7. What is the other name of Maxwell's right-hand thumb rule? Answer: the other name of Maxwell's right-hand thumb rule is Maxwell's corkscrew rule. Q8. State whether the following statement is true or false. The magnetic field inside a long circular coil carrying current will be parallel straight lines. Answer: true. Q9. What is the shape of a current-carrying conductor whose magnetic field pattern resembles that of a bar magnet? Answer: solenoid is the shape of a current-carrying conductor. Q10. State 3 ways in which the strength of an electromagnet can be increased. Answer: following are the 3 ways in which the strength of an electromagnet can be increased. A. By increasing the number of turns in the coil. B. By increasing the current flowing through the coil. C. By reducing the length of the air gap present between the poles. 11. Fill in the following blanks with suitable words. Ans. A. The lines of magnetic field round a straight current-carrying conductor are in the shape of concentric circles. B. For a current-carrying solenoid, the magnetic field is like that of a bar magnet. C. The magnetic effect of a coil can be increased by increasing the number of turns, increasing the current, or inserting an iron. D. If a coil is viewed from one end and the current flows in an anti-clockwise direction, then this end is a north. E. If a coil is viewed from one end and the current flows in a clockwise direction, then this end is a south. Q12. Describe how you will locate a current-carrying wire concealed in a wall. Answer: a current-carrying wire concealed in a wall can be located with the help of magnetic effect of the current by using a plotting compass. As the plotting compass is moved across the wall, a deflection is observed on the needle at the place where current-carrying wire is concealed. Q13. Describe some experiment to show that the magnetic field is associated with an electric current. Answer: a thick insulated copper wire ab is placed in the north-south direction as shown in the figure. A plotting compass M is placed under the copper wire ab. Both the ends of the wire are connected to the battery with the help of a switch. The compass needle is parallel to ab when there is no flow of current. As the current flows through the wire ab, a small deflection is seen in the needle. Therefore, the deflection in the needle is used for detecting the magnetic field associated with an electric current. A. Draw a sketch to show the magnetic lines of force due to a current-carrying straight conductor. B. Name and state the rule to determine the direction of magnetic field around a straight current-carrying conductor. Answer: A. Lackmersing Solutions Class 10 Physics Chapter 2 Magnetic Effects of Electric Current 3b. The rule that is used for determining the direction of magnetic field around a straight current carrying conductor is Maxwell's right-hand rule. According to the rule, the thumb points at the direction of the current and the direction in which the fingers have encircled the current carrying conductor gives the direction of the magnetic field lines around the wire. State and explain Maxwell's right-hand thumb rule. Answer: according to Maxwell's right-hand thumb rule, when a current-carrying conductor is held in the right hand, the thumb gives the direction of current and the fingers that have encircled the conductor gives the direction of the magnetic field lines around the wire. Consider a straight current-carrying wire which is held vertically in the upward direction from A to B. The wire is held as in the given figure. To find the direction of the magnetic field lines that is produced when the current flows through the wire, the thumb gives the direction of the current. The fingers that are encircled around the wire gives the direction of the magnetic field lines. The direction of the magnetic field lines is in the anti-clockwise direction. What is Maxwell's corkscrew rule? For what purpose is it used? Solution: according to Maxwell's corkscrew rule, imagine driving a corkscrew in the direction of current, then the direction in which we turn its handle is the direction of magnetic field. This rule is used to determine the direction of magnetic field around a straight current-carrying conductor. A. Draw the magnetic lines of force due to a circular wire carrying current. B. What are the various ways in which the strength of magnetic field produced by a current-carrying circular coil can be increased? Answer: B. The strength of the magnetic field produced by the current-carrying circular coil is increased by increasing the number of turns of the wire in the coil and by increasing the current flowing through the coil. State and explain the clock face rule for determining the polarities of a circular wire carrying current. Answer: according to the clock face rule, to look at one face of a circular wire when the current is passing through it is I. When the current around the face of the circular wire flows in the clockwise direction, then that face of the circular wire will be south pole. 2. When the current around the face of the circular wire flows in the anti-clockwise direction, then that face of the circular wire will be north pole.